Okay, just wanted to show you guys how to do that regression, the exponential regression with the calculator. On the original video, I had done it with just done it by hand, which it works out really great when this right here is a nice pretty little line. But when this is all over the place, it makes it a little harder, because I was able to just go through and divide and figure out what the R value is going to be, the common ratio, just by dividing 172.1 divided by 180.4, and then I could plug it in. But that only works if this right here is pretty. So the options that I have when this is not pretty is either to take and divide this and get that value and divide it by the difference over here. That's one way of doing it. Or you use your calculator, which I had kind of discussed in the video, but I didn't have one at hand because I was at home and apparently no longer have one at home. So let me show you how this works. So if I want to do a exponential regression equation in my calculator, right? So when you see that regression equation, that tells us that we can use our calculator to make that happen. And the way I go about doing that is we go Stat, Edit, enter in all of our data, right? So I'm going to go straight down the line 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, right, and 13. Okay, and then do the same thing for line 2. So just go through and enter your data. 180.4, 172.1, 164.2, 156.6, 149.4, 142.5, 136.0, 129.7. Right, so I'm just entering all this data. I know you don't really need me to read it out loud, but I just can't help it when I'm punching in numbers to read it out loud. Goodness gracious, right? So I've got it all entered in. Okay, always double check to make sure your bottom lines match up. If you have more than one than the other, it means you missed something somewhere. Go back and double check them. So I'm lined up on the bottom. I have the same number in both. Now, to create our linear regression or our exponential regression equation, okay, all you got to do is go back to that same stat button. Okay, so that same stat button, which is right here underneath my finger on the right hand side of your screen. But instead of doing edit, go over to calculate. Okay, and they told us it was exponential. Even if they didn't tell us it was exponential, you can kind of figure that out. But they told us this thing was exponential. So we're going to scroll until you can either scroll. I went up. Sorry, let me go down. So just scroll through, right, until you see the exponential regression. EXPREG, exponential regression. Right, so hit enter. Should pop up on your screen like that, exponential regression. Hit enter one more time. Its default is to use line 1 and line 2. And what it does is it gives us that exact same equation. So if you remember from the first video, that's pretty much what I had, only I rounded. So I had 180.4, whereas this has 0.954. So there's my regression equation, right? And they tell me even where to put it. A is going to be the 180.4. The B value is going to be the 0.95. So I'm going to use that. All right, so I've got y is equal to, plug those in, 180.4 times b, which is 0.95, to the x power. All right, so there's my regression equation. Okay, and so whenever I do that, even if these numbers weren't in perfect sequential order, I would still get a nice, pretty exponential equation that represents it. And then it says, when is the soup at temperature of 90 degrees? So then, if I wanted to figure that out, the easiest, fastest way to make that happen would be, again, the way I did it before was just to continue this multiplying by the 0.95 each time until I ended up with at least 90. The other option there is to plug this in my calculator, right? So I can make a y equals just by plugging that in. So I'm going to literally go up to, let me side by side here. So I'm going to go to the y equals button. Okay, so I go to the y equals button, punch in that equation that I just made. So 180.4, right, parentheses 0.95 raised to the, right, so this is how you do raised to, oops, sorry, I'm off the screen. Right, so this little caret thing underneath the clear is how you do an exponent. I accidentally hit 7. That's how you do the exponent, and then this is the variable button, right? The x, t, theta, n, that's your variable button. So that'll put an x in there, okay? And then close that parenthesis up, right? So then from there, I can either graph it if I want to by hitting the graph button, or I can look at the table of values by hitting second graph, which will give me the table, right? The blue button there is table. So then looking at the table, all I have to do, these are my minutes, right? The left-hand side, that was my minutes because that's what I put into that left-hand side were the minutes. And then the output is the actual temperature. So I'm looking for where the temperature was at 90. All right, so when you want to scroll with the X, Y, you can't scroll from the Y. It'll go up to the Y, and we don't want that. Instead, you got to go over to the X. So we're looking for a Y value or a temperature that was at 90. Okay, so at 13, we're still at 92, so that hasn't cooled quite enough. So we're going to have to go with the 14 because that's when it's going to drop down. So 14 minutes will work for that. Okay, so 14 minutes. There is a way to get an exact using logarithms, but I'm okay with you using a decimal. That's fine. So 14 minutes there. If you wanted to find the exact, that's where you would use the logarithms. We talked about logs in class. That's where you would use that. And then what is the predicted temperature of the soup after 1 hour? Okay, so then if I want to look at it after 1 hour, a great thing is it's already in my calculator, right? 1 hour, remember these are in minutes. So I just need to scroll all the way down to 60 minutes. All the way down, all the way, all the way, all the way, all the way down. Right, do keep in mind that this thing is going to keep a little more accurate record. Oops, passed it up. This thing is going to do a little bit better with the decimals than I did when I was doing it with my little fun calculator on my computer on the video before. So after 1 hour, they give me 0.8311. Okay, and that's just the difference of the decimal rounding that I did versus what the calculator is going to do. So 8.311 is going to be the predicted temperature after 1 hour. Okay, so that's how you do that in the calculator. Okay, calculator buttons real quick one more time. You go stat, edit, right, just hit enter on the edit there, and then input both values, right, so input both of the columns of values, and then go back to stat, right, but instead of hitting enter on the edit, we're going to go over to calc, and then we're going to go down and find, this is where I would find, if I wanted to find linear regression, that would be right there. Make sure you use the AX plus B form, and then if it's exponential, which this one said it was exponential, so that's why I knew this one was, it says exponential regression. So go to your exponential regression, hit enter, it spits it out for you, okay? And then you just plug those A and B values in and you're done. That's how you get an exponential regression equation to represent that data, okay? Good luck with all of that.